Welcome to our channel. Watch the video until the end, leave a like, and subscribe to support us.
When we look at the night sky, we see a sea of stars, but despite there being trillions of light sources in space, the entire cosmos appears dark. How is this possible? The real reason why space is dark will surprise you. This apparent discrepancy in the night sky, known as Olbers' paradox, raises questions that have intrigued astronomers for centuries. The answer lies in the depths of the foundations of our universe, revealing secrets about its structure, its age, and the very nature of light. Imagine having 20 small LED lights in a dark room. These small lights would be enough to significantly illuminate a room. But in space, the effect seems very different. Trillions of bright stars do not seem to be able to light up the universe even approximately, and so it appears predominantly dark or black. Yet each of these stars is a blazing furnace emitting gigantic amounts of light and heat. Our sky on Earth is bright only when it is directly illuminated by our star. If we turn away from the sun, the stars begin to twinkle in the night sky. But the sky and Earth are largely dark.
Let's take an imaginary journey to discover the mystery of light and darkness.
At night you find yourself in a large open field with a flashlight in hand. Around you are friends with their flashlights, some very close to you, others far away. Now, imagine that each of these flashlights represents a star in space. Outdoors, the effect of light is very different from that of enclosed environments. It will not be able to intensely illuminate the surrounding environment with your flashlights. The light fades more and more, and the environment remains predominantly dark. Space is not a closed space. At least, we have not yet found any boundaries, and the distances between the stars are enormous. Compared to the large spaces between the stars, there are very few light sources, and in the empty space, there are no objects that can reflect the light. Therefore, light disperses very differently compared to a room. What is still interesting in this context is the fact that, despite this plausible presentation of light distribution, there is no real explanation for why space appears dark.
Olbers' paradox explained.
The physician and astronomer Heinrich Wilhelm Olbers thought more or less the same thing when, in the 18th century, he looked at the sky and saw all those stars in the dark. In the 18th century, people's rooms were still lit by fireplaces, candles, or oil lamps.
Olbers wondered why the bright spots could not light up the sky.
These reflections gave rise to Olbers' paradox and the question of why the night sky is dark despite there being an infinite number of stars in the universe, something that has occupied astronomers for centuries. At the time of Olbers, it was still thought that the universe was static and a limited space. All objects had a fixed place within it. And it was somehow also thought that all the stars visible from Earth were arranged next to each other. At the time, no one had the slightest idea of how large the universe really was and that the light from the stars we see partly came from stars that existed millions or billions of years ago and whose light had traveled to us for an incredibly long time.
Olbers and his colleagues did not even know that the light from a large distant star could shine more in the night sky than that of a smaller nearby star. From the beginning of the 20th century, astronomers have known the real extent of the universe, the movements of all objects in space, gravity, and dynamics. It was then discovered that the universe is probably not infinitely old. It had a beginning called the Big Bang, and since then the universe has begun to expand and is not yet old enough for light to reach us from everywhere. Some stars are so far away that their light has not yet reached us, and since the universe is expanding, some stars are moving away so fast from us that their light will never reach us. If we were to transfer the real dimensions into space with LEDs, the idea of a single LED in an otherwise dark soccer stadium would not be enough to describe the true dimensions of the universe. Let's delve into the true dimensions of the universe.
Imagine that the sun is a bright orange. If we placed this luminous orange in Berlin, the nearest star, Proxima Centauri, would be as far away as a second orange in Madrid. This helps us understand how huge the intermediate space is, and it makes us realize that it is a real miracle that the light from the Berlin orange is visible in Madrid just as we can see the light from stars thousands of light years away.
We humans underestimate the dimensions of the face of the universe when we look at the sky and see the sea of stars.
The thousands of points of light that we see compressed together in a mass in the night sky are actually unimaginably distant in terms of space and time. Their trails of light appear as a luminous carpet only to our eyes, but this does not explain why the space between the stars is dark. In reality, interstellar space is not black at all. We travel again through space and explore just the space between light sources. The space between stars is often described as a void, but it is not completely empty even though it seems so. It is filled with gas and dust distributed very thinly. Since the Voyager probes were the first human-made objects to fly in this space, we have known for the first time what is really there. Before then, scientists had made estimates that, apart from the particle density, corresponded broadly to the actual observations. Imagine interstellar space like a very light breeze that you can barely feel, or like dust particles that you can only see in sunlight but that are everywhere in the air. In this interstellar space, there are also magnetic fields and particles that are swept away by the sun and other stars. Along with cosmic rays traveling through the universe, however, the density of particles and gas is so low that one can almost speak of empty space, and because there is so little matter, almost nothing can reflect the light, so here it is dark. One might wonder, however, what interstellar space would look like if it were lit up. Just think of the planet Pluto, which orbits at such a distance from the Sun that it is almost invisible. Everything around Pluto is dark, and that's why we didn't have a photo of the planet for a long time. Just because it's dark where Pluto is located, that is, there is no light, doesn't mean that Pluto doesn't have colors. However, we were only able to see them when the New Horizons probe exposed Pluto with a special system of cameras. The situation might be similar for interstellar space. If it were illuminated, perhaps it would be purple, or we might recognize structures that we cannot yet see because there is no light. Thus, interstellar space is neither black nor dark, but simply devoid of light. Although empty space is traversed by light, it does not illuminate the space because there is no matter to reflect or scatter the light. The light from our star is reflected and scattered by the particles in the atmosphere, so the darkness of the universe can only be explained by the lack of light. However, we do not know what colors the universe or empty spaces would be if there were light. The question of whether dark matter colors space darkly is interesting. The name suggests that dark matter gives a dark color to the universe. After all, it is said that dark matter makes up 85% of the universe. However, dark matter is not matter in this sense. It is rather an idea of an invisible substance that acts like a kind of glue in the universe. Researchers have discovered the existence of this matter by observing galaxies. Previous ideas and physical theories were not sufficient to explain the formation and dynamics of movement within galaxies. Another enigmatic agent is said to be dark matter. The secret of dark matter is that it is invisible. It is not really dark just as black holes are not black, but also invisible. This form of matter is dark because it does not emit light and does not reflect it. Dark matter is therefore dark because it is invisible, and the surrounding space is dark, so the mysterious space colors the dark matter, not vice versa. Why do astronauts not see the stars? It seems absurd, and yet it is true. Astronauts hardly ever see the stars in space, even though in reality the view of the stars should be limited. The issue of why this situation occurs also has to do with various aspects of light perception and camera technology. When we see images or videos from space, the sky appears strangely black and almost no stars are visible. The fact that astronauts do not see stars in space is only partly true. Under certain conditions, the starry sky becomes visible, but the optics are different from what we know from Earth. First, it is important to understand that human perception of light depends strongly on environmental conditions. In space, where there is no atmospheric light to obscure the stars or blur the view, the stars are actually much brighter and clearer compared to Earth. The problem of visibility of the stars in space often occurs due to the strong contrast between the bright sun and the deep black of space. When astronauts are in sunlight, the intensity of the sunlight can significantly narrow the pupils, reducing the eye's sensitivity to the light of the weaker stars. This can make the stars less visible or not visible at all while the eyes adjust to the intense light. In a brightly lit area like the International Space Station or during a spacewalk in sunlight, astronauts' eyes are optimized for bright conditions and are less sensitive to the weak light of the stars. However, in the darkness of space, away from the direct light of the sun or other light sources, the eyes can adjust and make the stars clearly visible. Astronauts have reported being able to see the stars clearly and in large numbers in the shadowed parts of a spaceflight or during the nighttime side of Earth's orbit.
Most images and videos captured by spacecraft or astronauts often do not show the stars because the cameras are focused on very bright objects such as Earth, the space station, or the astronauts themselves. To capture these objects and the distant stars, which are much dimmer, at the same time, camera settings need to be adjusted, which rarely happens without a specific intention. Long exposure times would make the stars visible. These technological and scientific details show how the interpretation of light in images in outer space differs significantly from that on Earth, reflecting the complexity of our visual perception and the tools we use to explore the cosmos. With these insights, we can better appreciate the immense vastness and mysterious beauty of the universe around us, remembering that every discovery leads to new questions and wonders.